have that our good old friend Angel has 520 in his savings account. Okay, there's going to be a lot of context here. Okay, but a lot of this context is actually a big hint for the buzzwords needed to use for this exercise. Remember, whichever buzzword or keyword or key concept that you use will lead us to the formal booklet and will lead us to the procedure. Sometimes it will lead us straight to the procedure and the tools will not be in the formal booklet. Let's see what happens in this case. So, we have $520 in his savings account, and Angel considers investing the money for 5 years with a bank. The bank offers an annual interest rate of 1.2% compounded quarterly. And so for part A, we need to calculate the amount of money Angel would have at the end of 5 years. So at the end of 5 years with the bank. Give your answer correct to 2 decimal places. Important step there, don't forget it. So, the biggest sort of buzzword or hint that should be happening here is that the moment you read something like compounded quarterly, you're talking about compound interest. And so from here, you guys, the big hint is that because you're talking about compound interest, you can go to the formal booklet, search for compound interest, and here it is. And so as you can see, you can simply use this formula and get away with it. See? Now this formula has a lot to it, but plug in this stuff piece by piece and everything will be fine. There's 2 types of exercises that you can face with these compound interest problems. See? You could have a version with PMT or you can have a version without PMT. And what I really need you to understand is that if it's with PMT, you have to use the calculator. And if it's without PMT, you can use the calculator or the formula booklet. See? So if it's without PMT, you can use this guy. If it's with PMT, you have to use a calculator in the finance app. Finance app. I should have put that parentheses earlier. The calculator in the finance app, which is this guy here. You press apps, the purple button, and go to finance. And TVM solver. See? So you can either use this or you can just plug in like sort of manually. Okay, they both work. I'm not sure which one I'm gonna use. I think I'll use the one in the calculator just so that whatever. It's more friendly, I guess. See? Now, I'm talking about PMT. What the heck is PMT? PMT, okay, what is something you're gonna use whenever you have something that is like additional monthly payment. Okay? It's not compounded monthly. It's something that is like an additional sort of payment. And so the context for this could be like, I don't know, Polly buys a car, and so my good old friend Polly bought a car, and in order to pay off the debt more quickly, he puts in an additional monthly payment. Okay? So PMT is additional, which is like an additional in respects to what you're already compounding monthly. Okay, so keep that in mind. PMT is whenever we're talking about something additional. For part A, there is no additional. Okay, for part A, there is no additional. And so here, because there's no additional, I could just use this formula or I could use the finance app. I'm going to use the finance app because, I don't know, it's what tends to happen more. See? Now, for the finance app, the annoying part about it is that there's a lot of different methods. See? If you actually go over here, for example, here you have 2 methods, right? You can use the financial app, but there's a lot of different stuff going on here, right? Or also, you can simply use the formula from the formal booklet. Okay, they both work. Now, the big problem when I try to explain the use of the financial app is that people get confused with what is PYCY, why is it different in this case, and why is it the same in this case? Which strategy should I use? Which one is more convenient? And what I suggest, okay, is sticking to the version where they are both the same. Now notice, the main difference between these two is that, well, yeah, these two things are different, cierto? Clearly. But why? They're different because of how you express big N. Okay, this N is big N. In this formula over here, you have K times little n. Okay, what am I trying to reach here? The method on the left, okay, if you plug it in like what's on the left, this big N is going to be the same as little n, okay? If you use the method on the right, which is what I suggest, this big N is going to be the same as the formula booklet. It's going to be K times N. That is what I suggest. Because if you use the big N, which is K times N, you can simply leave PY and CY with the same value, okay? And so just, I know that maybe for now it's a little bit confusing. What is K, what is N, what is happening? For now, first of all, I'm going to say use the method on the right, forget what's happening on the left. Your big N is going to be K times N, and these two values down here are going to be K. For me, this is a lot more friendly to remember rather than trying to figure out why PY and CY are different. See? So that is just my approach that I like to suggest. For me, it's easier to remember because if big N is K times N, you can also remember that from the formula booklet more visually. Okay? So let's go piece by piece. See? Big N is K times N. What is K in this context? So K, let me use a different color because there's a lot of stuff going on here. So K is the number of compounding periods per year, while N is the number of years. See? So compounding periods per year, the big hint here is like, if you talk about quarterly, well, how many quarters are there in a year? There's 4. If you're talking about monthly, you would have 12. If you talk about yearly, you would have 1. See? So in this case, because it's compounded quarterly, it's a massive hint for saying that, K is going to be 4. What else do you know? 5 years, N is going to be 5. So, big N, for our approach, ¿cierto? Big N is going to be 5 times 4. Big N is going to be 20. That is why there's a 20 here. See? What else can you identify? Well, the I over here, which is I%, see, it's going to be the interest rate. It literally tells you here it's going to be 1.2%. So that is where that appears. See? So big N, we're going to put it as 20. The percent, it's already as a percent, so all you have to do is do 1.2. PV is your present value. Okay, it's your present value. And if you can see over here in the approach that they suggest, ¿cierto? They put it as positive or negative, right? And this is just a context thing. It depends how you think about it. See? You can think about it as that Angel just lost $520 by putting it in the savings account, or Angel still has 520 and leave it as a positive sort of value. Okay, what I like to do is think about it as Angel losing money initially. So Angel has 520 in the savings account. It went from his pocket to the account, so initially he loses. This is just a mentality thing. You pick your approach. See, so I'm going to put it as negative 520. PMT is going to be 0. FV is actually what we're trying to find because FV is the amount of money that Angel will have at the end of 5 years. See, so FV is actually what we're going to be solving for. PY and CY, as I said, is simply going to be K, and K we said was 4. See? So 4 and 4, bada bim, bada boom. Now, how do you solve from here? You actually have to use the solve button. Where is the solve button? Right above enter in green. So that means you need to press alpha, and enter is going to make you hit the solve button. Now, because you're solving for FV, make sure you press the solve button while standing on FV. Basically, you're asking the calculator, using all these parameters, what should FV be? FV ends up being that amount. And notice it gives it to you in a positive value, which for me makes more sense. For me, it makes more sense because Angel initially lost 520, putting it in the account, and he ends up with 552 or $552. See? So the answer from part A, using all that sort of lengthy approach, is $552.20. 105. 4166. 4116. Sorry. Now, the disclaimer, because the IB loves disclaimers, is that it needs to be corrected 2 decimal places. So different to significant value, which you would count from left to right, here you have to start from the decimal place. So you count 1, you count 2. Do you round it up or keep it the same? You round it up because it's next to a 5. So for part A, you actually leave it as 552.11. Is it dollars? It's dollars. There it is. See? If we look at the answer, here it is. Bada bim, bada boom. So that is for part A. See? Now, all that analysis didn't matter because for some reason, instead of investing the money, Angel decides to buy a phone. Freaking millennials, am I right? Angel decides to buy a phone that costs 520. At the end of 5 years, the phone will have a value of $30. It may be assumed that the depreciation rate per year is constant, and so calculate the annual depreciation rate of the phone. Now, this is a little bit different, see? Notice that here we're not talking about any compounded quarterly, any compounded this, compounded that. We're talking about depreciation, see? So for these sort of compound interest problems, yes, like once you identify that you're talking about compound interest, you gotta talk about if it's PMT or not PMT, and there see if you use the finance app or not, see? But the other sort of type of exercise that can appear is either an appreciation exercise or a depreciation. So if something depreciates, okay, we're talking about an exercise like this one, see? And so for depreciation for part B, what's happening, right, is that like on year 0, ¿cierto? The phone costs 520. On year 1, it costs a little less, then a little less, then a little less, then a little less, then a little less, and on the last year, it's now worth $30. See? And so the exercise you sort of have to do is see by how much is it decreasing each time until it reaches $30. Now, because it is constant, right, that means that it is always multiplying by the same amount. See? And this is it's a very specific approach. See, so this is the kind of thing that it's not in the formula booklet. And so in this case, you're going to be identifying the buzzword of depreciation and going straight to a procedure. There isn't a formula in the formula booklet for this, but there is a formula that you can learn. So the formula that you're going to learn is that technically you take your value, you multiply it by the depreciation, and you have it to the power of the years that happens, and here you're going to have the final value. All right, so this is a sort of formula that you do have to memorize, you do have to remember. So you're going to have the 520, parentheses, 1 minus the depreciation rate to the power of the years will equal the final value. So I know that I changed the formula a little bit, but the reason this happens is the following. Think about it this way. And this is just for context of the formula. See, I'm not going to do the exercise yet. For context of the formula, let's imagine that the depreciation is 5%. See? If you use the one up top, which is like the wrong formula, so my bad, but I'm glad this happened because now I can show you the exercise. If you say that the depreciation is 5%, let's say that it's just for 1 year. See? If the depreciation is 5% and I use the one up top, what you end up with is 520 times 5%, which is 0.05. And what you end up with, if you notice here, you end up with 520 times 0.05. And so that means that in 1 year, you went from $520 to $26. Now, if it were depreciating 5%, you would expect the number to be a little closer to 520, right? But in this case, we literally ended up with 26. So what's happening here? What you actually just did is that you depreciated it by accident by 95%. Okay, so whenever you want to express the depreciation, you actually have to do 1 minus the depreciation rate. If here you do 1 minus, you end up with 1 minus 0.05, which of course is actually going to be the same as 520 times 0.95, right? And so that makes more sense. There we have a depreciation rate of 5%. My number is much closer to 520. See? So be careful about that. It's a classic mistake. The same for when it's growing. Okay, if it's growing, you gotta do 1 plus your amount, right? Same idea, see? So in this context, we're gonna apply the formula that is on the bottom. Now that we understand how it works, it's a lot more friendly. So we're gonna have 520 times 1 minus, and here we need to calculate the annual depreciation. So of course we're gonna have 1 minus x to the power of, well, we're saying it's 5 years, see? So 5 years is going to equal my final value, which we said was 30. Now you might be thinking, damn, how the heck do you solve this? There's a couple different ways, and the main issue here is that you have 1 minus x to the power of 5, which is crazy hard to solve. No one expects you to do that by hand. I guess you could, but why would you? See? Because we have our calculator, what you can do is something a lot more friendly. You can ask your calculator, if this is y1 and this is y2, when do they intersect? If you express both of them as lines and find where they intersect, that's going to be where they equal each other. And wherever they equal each other is going to be the x value that you need. So let's see how that actually works. Go to y equals, and this is something you can always use, by the way. Whenever you have an equal sign and one value of x you need to find, you can just pop it into your calculator. It might take a little bit longer to solve, but it's going to work. So 520 parentheses 1 minus x to the power of 5 has to equal 30. So there's my y1, there's my y2. Go ahead and find the intersect. So calc, so second calc, right? I mean second trace. So hit calc, go to intersect, see what happens. Well, the first thing that happened is that only one of my lines appears. So think about context-wise, how can I make the other number appear? So this curvy sort of line has to be y1 because y2 is 30, so it's going to be a straight line. So let's go to window and let's try to make that straight line appear. So if I make my y max, for example, 40, I know it's going to appear barely, right? I don't care about negative values for y because we are talking about a because y equals 30. I need to see the intersect. It's not going to be at a negative value for y. It might be for a negative value for x. This is probably fine. Let's go ahead and graph it. See? So now I should be able to see my y2, and it shows up right there. So now, if you find the intersect of that, the first curve we check is the blue line, so we're good there. The second curve is the red one, and then we have a guess. Now guess is really whenever you have more than one intersect. Here we have just one, so just pop it near it. That is the value it gave me. So let's get good at interpreting this. So this gave me 0.43477, 0.43477 comma 30. So as you can see, my y2 is right here. Well, for my y1, or really my x value, is right there. So that is how you interpret the calc intersect trick. I used it because I had 1 minus x to the power of 5, which is very hard to solve. See? So the calc intersect trick is something that always works. And so for this context, you would say that the annual depreciation rate of the phone is going to be 0.43477 to 1. Or you can leave it, I guess, context-wise as a percent. It would be 43.3 significant figures, you would leave it as 5%. See? So that is our answer for part B. Let's see how they have it over here. 43.5%. See, so as you can see, there is the same sort of formula that I used. You could have done it with the finance app. See, you could have done it with the finance app. I guess it also would have worked. But for me, the depreciation rate is much more friendly to think about it like this. Okay, this is a classic formula. It always appears. You can use it for depreciation or appreciation. I'd rather show the depreciation appreciation with this and the compound interest with the finance app. See? So both approaches work. That's the one I employed. I hope it helped. That is for number 2.